A pleasant greetings to all. In this video, I am going to explain one important topic in the digital electronics, that is flip-flops. What is flip-flop? Flip-flop is a single bit storage element. It can store binary 1 or binary 0. Single bit storage element. It can store binary 0 or binary 1. Then the memory element used in the clock sequential circuit is flip-flop. Clock sequential circuit is flip-flop. Third, the flip-flop is triggered either by positive or negative edge-triggered signal. Positive or negative trigger signal. These are about some of the basic points of flip-flop. Next, I am going to explain types of flip-flop. The first one is SR flip-flop. Second, D flip-flop. Third is T flip-flop. Fourth one is JK flip-flop. One of the most simple sequential circuit is SR flip-flop. In this video, I am going to explain about SR flip-flop. What is the other name of SR flip-flop? SR flip-flop is otherwise known as set-reset flip-flop. This is SR flip-flop. First of all, I am going to draw the symbol for SR flip-flop. So this is the symbol. The center put clock. Here S and R. Here Q and Q bar. This is the symbol for SR flip-flop. Okay, next I am going to explain how to draw the logic diagram for SR flip-flop. To draw the logic diagram for SR flip-flop, how many NAND gates are required? There are 4 NAND gates are required to draw the logic diagram for SR flip-flop. Draw the first NAND gate. Next, draw the second NAND gate. Next, third NAND gate. Fourth NAND gate. So I have to put the number for gates 1, 2, 3 and 4. The first NAND gate, apply the input, that is yes, because this is the SR flip-flop. The first NAND gate, apply the input yes. Third NAND gate, apply the input R. In between, the clock signal is applied. And then, output of the first NAND gate is given to the input of the second NAND gate. And output of the third NAND gate is given to the input of fourth NAND gate. Next, output of the second NAND gate is denoted as Qn, and that is connected to the input of fourth NAND gate. And next, output of fourth NAND gate is Qn bar. This is the present input that is connected to the second NAND gate. And what is the next state? Qn plus 1. Here Qn bar, next state is Qn plus 1 the whole bar. Okay, this is the logical diagram for SR flip-flop. After finishing the logic diagram, I am going to draw the truth table. And here I am going to explain how to draw the truth table for SR flip-flop. Here this SR flip-flop is known as clocked SR flip-flop. So in a clocked SR flip-flop, clock signal is used as the input. Okay, first we'll draw the clock signal, clock, and then for present input, and next present state and next state output. The last, what about the state? So first clock, next present input. The present inputs are yes, or. Present state and next state is Qn, Qn plus 1. This is the state. Next I am going to put the value one by one. There are 8 set of clock signal is applied here. So first of all, I have to put all the clocks are 1, 1, 1, 1. All are 1. First combination for SR is 0, 0, and the Qn value is 0. Second combination also 0, 0. The present state we have assumed as 1. Third combination 0, 1, 0, 1, and here 0, 0 and 1. Two present states. Next 1, 1, 0, 0, here 0, 1. The last also 1, 1, 1, 1, 0, 1. And next I am going to explain how to find out the next state. First what I have to do, I have to put the values for S. S is equal to 0. And next R equal to 0, clock equal to 1. What about the output of the NAND gate? 0 into 1, 0, bar 1. Here also 1. Qn is 0. First assume Qn is 0, then 1. So 0 is connected here. We'll get Qn bar is 1. The same one is connected here. The next state I'll get the first value was 0. And next Qn equal to 1 is connected to the input of 4. So 1 into 1 equal to 0. 0 into 1 is 1. Next state also 1. For both the condition, the first we get 0 and second condition we get 1. This is the Qn plus 1. Is there any change in the state? No. No change. No change in the state for both cases. And next what I have to do, I have to apply S is equal to 0 and R is equal to 1. For this case, I am going to find out what about the change in the next state. For this, R equal to 1. 0 into 1 is 1. 1 into 1 is 0. Here first assume Qn equal to 0, next 1. So first value 0. So 0 into 0 is equal to 1. Okay, 1 into 1 equal to 0. So first we will get the value was 0. And next 1 is applied. So instead of 0, we have to apply 1. 0 into 1, again 1. 1 is connected, again we will get a 0. So present state is 0 at that time, the next state is 0. Present state is 1, at that time we get the next state is 0. 0 and 0. Irrespective of the present state, we'll get both the outputs are both the next states are 0. So what is the meaning here? Reset. Reset is occur. Because reset is 1, so both are equal to 0. And check for the next condition. S is equal to 1 and R is equal to 0. This is the condition. Okay, now I have to substitute. Here there is no change. Okay, S is equal to 0. No, S is equal to 1 and R equal to 0. 1 into 1, the whole bar, that is equal to 0. Then 1 into 0 bar equal to 1. First apply the present state 0. 0 into 1, that is 0. 0 into 0 is 1. Next state is 1. And next, apply the value 1 instead of 0. So 1 into 1 also 0. 0 into 0 is 1. So 1 and 1. So what about the state here? The set. Set is equal to 1. Reset equal to 0. So what about the next state? Next state also set. And next we have to check for the last condition. In the last condition, S is equal to 1 and R is equal to 1. This is the last condition. I am going to check the last condition. 1 into 1 is 0. 1 into 1, that is 0. Here 0 into 0 is 1. 1 into 0 is 1. And next, I am going to check the next condition. Next condition is 1. So 1 into 0 is 1. 1 into 0 also 1. And here both are equal to 1. So it is not possible. This condition is not possible. So put X. This is the indeterminate state. Indeterminate state. So these are about the twos table for SR flip-flop. After completing the twos table, what I have to do? K-map simplification. K-map simplification. For the K-map simplification, I am going to take S, R, Qn. Using this, I am going to find out the equation for Qn plus 1. So S or Qn only have used 3 variables. So 3 variable means 2 power 3. 8 cell coordinate map is needed. So in 8 cell coordinate map, I have to place the value S or Qn. Here put 0, 0, 0, 1, 1, 1, 1, 0. Here 0 and 1. S or Qn 3 equal to 0. The answer is 0. and 0, 0, 1, 0, 0, 1, 1, x and x. Now I am going to combine the cells together. The maximum cells are combined together, including don't care state. Then only the logical expression is somewhat reduced. So Qn plus 1 equal to, here what about this? This is R bar Qn plus this one is S. This is the logical expression for the SR flip-flop. And afterwards, I am going to find out the function table or characteristics table. So what is the function table? In the function table, what are the values I am going to take? That is S, R, then Qn plus 1. Okay, first value, S is equal to 0 and R is equal to 0, Qn plus 1 is Qn. No change in the state. Second, S is equal to 0, R equal to 1, reset, that is 0. And next, S is equal to 1 and R is equal to 0, set, that is the state. Both are equal to 1, indeterminate state. So this is the function table. Next I am going to explain how to draw the modified truth table. Our main aim is to draw the excitation table. So once we draw the modified truth table, then only we can draw the excitation table. So first of all, I am going to explain how to draw the modified truth table. To draw the modified truth table, what I have to do, first of all, I am going to take the first column as Qn, second Qn plus 1, third S, and fourth column R. So first of all, Qn means 0, 0. You have to take 0, 0, 0, 0 only. So 0, 0, 0 and 0. What is the corresponding values of S and R? S is 0 and R is 0. For this 0, 0, S is 0 and R is 1. Okay, how to write this? S is no change. So simply have to write 0 and R is changed from 0 to 1. So I have to put the value as X. And next consider 1, 1. Here 1, 1. Or sorry, next consider 0, 1. So only 1, 0, 1 is there. So 0, 1. For 0, 1, what about S? S is 1 and R is 0. And next consider 1, 0. Okay, 1, 0. So 1, 0, what about S? S is 0 and R is 1. The last condition 1, 1. Both are 1, 1. So I put the condition here 1, 1. So 1, 1. S is 0 and R is 0. Next 1, 1. S is 1 and R is 0. So instead of 0, 1, I have to put X, and instead of 0, 0, simply put 0. So this is the modified truth table. From the modified truth table, I am going to draw the excitation table. What is the excitation table? Excitation table also the same. So first I have to put the same as Qn plus 1, S and R. Qn plus 1, S then R. Here first put 0. Any one 0 I have to consider 0. 0, 0, 0, X. And next one is 0, 1, 1, 0. Next 1, 0, 0, 1. And the last 1, 1, X, 0. So this is the excitation table for the SR flip-flop. After finish the excitation table, I am going to explain about the state diagram. How to draw the state diagram for SR flip-flop. So to draw the state diagram, 0, first one circle, put one circle and 0. And next draw another one circle. Here put 1. This 0 and 1 is known as present state. See, from the excitation table, S is equal to 1 and R is equal to 0. Present state is 0 and next state is 1. Okay, how to draw this 0 to 1? When S is equal to 0 and S is equal to 1 and R is equal to 0. Transition from 0 to 1. Okay. And next, when S is equal to 0 and R is equal to 1. S is equal to 0 and R equal to 1. Transition from 1 to 0. Okay. And then the next one is S is equal to 0 and R is equal to 0. S is equal to 0 and R is equal to 1. Okay, for this case. X may be 0 or 1, no? So 0, 0 or R is equal to 0, 1. The transition is the same only. 0, 0. The same state only. And next consider the last. S is equal to 0 and R is equal to 0. S is equal to 1 and R is equal to 0. 1, 0. The transition is from 1 to 1. 1 to 1. So put the direction like this. This is the state diagram. After finishing the state diagram, I am going to explain how to draw the timing diagram for SR flip-flop. Timing diagram. To draw the timing diagram, what are the parameters I am going to take? The parameters I am going to take is S, R, clock, then the next state Qn plus 1. Before that, I have to draw some dotted lines. Then only it is easy to locate the signals ESR, clock, then Qn plus 1. Okay, first I have to plot yes. Zero, zero, 1, 1, 0, 0, then 1, 1. I have to put the value here. 0, 0, 1, 1, 0, 0, 1, 1. This is for yes. And next, I am going to draw the next parameter R. Up to this, it is 0. Next one, again 0. 0, 0, 0, 0, 1, 1, 0, 0. This is R. After finishing this, you have to locate the clock pulse, positive clock pulse. So it is starting here. This is the positive clock pulse. Then you have to draw, continue like this. That's all. So positive, positive, positive clock. Put 0 and 1 here, 0, 1, 0, 1, 0, 1, 0, 1 and 0. And afterwards, how to draw Qn plus 1, that is the next state. See here, first S is equal to 0, R is equal to 0, clock pulse equal to 0. What about the output? Output equal to same, that is the present state. And the clock equal to 1, also the same. S is equal to 1, R is equal to 0 and clock pulse equal to 0, that is reset. Clock pulse equal to 1 means set. Clock pulse equal to 0, that is reset. This is Qn plus 1, 0, 0, 0. And next see here, 1, 0, here also 1. Now it is 1 because set. And then 0, 1, 0. In this time also set because reset but clock is 0. So we get the set value. And then see here set 0, reset 1, clock pulse is 1. Again reset. And then set 1, reset 0, clock pulse 0, again reset. Then set 1, reset 0, clock pulse 1, then set, and so on, 0, 0, 1. Okay, these are about how to draw the timing diagram for SR flip-flop. Up to this, SR flip-flop is over. Thank you. Have a nice day.